Alright guys, today we're going to be talking about finding limits using algebra, which is going to be a super important topic in your calculus class, especially as you start to talk about derivatives. So, first let's go over the steps. The first step is always to just plug the x value into the equation. So in this case, the limit as x goes to a of f of x, you're just going to plug in a into f of a. And if you get a value out, the limit's found, that's all you have to do, you're done. But if you get what's called an indeterminate form, which we're going to talk about in a second, more work must be done. So if we get an indeterminate form, we're going to use one of these three algebraic strategies to simplify the limit. So factoring, we're going to use that pretty often, generally whenever we see a polynomial of x over another polynomial of x. For trig identities, you're going to use that pretty much anytime you see trig because those are super helpful. And lastly, conjugates, you're going to do that whenever you see something like a square root of something minus a square root of something else, or plus a square root of something else. Then, once we've used one of these three strategies to simplify the limit, we're going to try and evaluate it again, and hopefully this time we won't end up with another indeterminate form. Okay, here's our list of indeterminate forms. The most common ones are these two on the left, and today we're only going to be talking about 0 over 0. But eventually we will talk about all 7 of these. Okay, canceling zeros. Normally, we can't cancel a 0 in the top and bottom of an equation without giving constraints. So in this case, if we wanted to cancel x minus a over x minus a, we have to specify that x is not equal to a. Because if x were equal to a, then we'd be canceling 0 over 0, which doesn't make any sense. However, when we're taking the limit, we will have to cancel this x minus a over x minus a. So how are we able to do this? Well, really we have to think back to the definition of a limit, which means that a limit is only defined when we take the limit as x goes to a plus and a minus, and we make sure those two values are equal. So what we're going to do is first we're going to plug in a plus. So if x is a plus, this is going to be 0 plus. And this is going to be 0 plus. And since these are not exact zeros, we can cancel these two. And we're able to do this. Same thing with 0 minus. We plug in x equals a minus, we end up with 0 minus here. And in this factor, we end up with 0 minus. So we are able to actually cancel these factors. So we're not going to go through all of these steps when we start solving problems, but it is important to keep in mind that that's the only reason that we're allowed to cancel zeros like this. Okay, so here's our first example. So the first step you're always going to want to do is to just plug in the x value here. So the limit as x goes to 2, 2 squared is 4, plus 2 minus 6 over 4 minus 6 plus 6. Okay, so this top is going to be 0, this is going to be 4. Now this is not an indeterminate form, this is just 0. So this means that we already solved the limit. That's all we have to do. That's our whole answer. However, that's not always going to be the case. For example, here, as we evaluate this, just plug in x equals 4, 32 minus 12 minus 20 over 16 minus 40 plus 24. And in this case, we are going to get 0 over 0. So this means that we're going to have to use one of our three strategies to simplify this limit, so that we won't get an indeterminate form. So since in this case we have a polynomial over another polynomial, we're going to use factoring. Now we already know that when x equals 4, both of these expressions on the top and the bottom are equal to 0. So I'm going to use synthetic division to get that 4 factor out. So this is 4, 2, 8, 5, 20. So all I was doing there was I was factoring this top part. So we know that this is x minus 4 times 2x plus 5, as you can see down here. And on the bottom, we're going to do the same thing. We're going to factor using synthetic division. We're going to factor out x minus 4. So 1 minus 10 plus 24, 4, 1, 4 minus 6 minus 24. So we're going to have x minus 4 and x minus 6. Okay, so now we're going to use that strategy we talked about before. Even though x equals 4, we are allowed to cancel this factor. because we're taking the limit. So now we're just going to plug in x equals 4 to this expression here. So we're going to have 13 over negative 2, or negative 13 over 2. And that is our answer. That's the value of this limit. Okay, now we have a bit of a trig limit here. So we're going to just start by plugging in this value. So cosine of 2 times negative pi over 4 is cosine of negative pi over 2, which is 0. And on the bottom, sine of negative pi over 4 is negative square root of 2 over 2. And cosine of negative pi over 4 is positive square root of 2 over 2, so we have a 0 over 0 situation. So now we're going to use our strategies to simplify this limit. Okay, so as I said, whenever you see trig, the first step is always to expand everything using trig identities. So here I see this cosine of 2x. I'm going to use the trig identity cosine of 2x equals cosine squared of x minus sine squared of x. Okay, and now obviously I can't cancel anything yet, but what I can do is I can factor this top part using difference of squares. And on the bottom we're still going to have sine of x plus cosine of x. And we're going to cancel this factor with the bottom. Again, the only reason we can do that is because we're taking the limit. So now we're just going to have cosine of x minus sine of x. Cosine of x is going to be square root of 2 over 2 because x is negative pi over 4. Sine of x is going to be negative square root over 2, square root of 2 over 2. So we're going to add that since there's a subtraction sign. And our answer is just going to be square root of 2. So that's this limit. And our last problem for today, I'm going to start by plugging in x equals 0. And as you can see, this is going to be 0 on the bottom, and square root of 5 plus 2 times 0 is just square root of 5. So this is again going to be 0 over 0. Now, as I talked about in the beginning, whenever you see square roots adding and subtracting, you're going to think to use conjugates. So I'm going to start by multiplying the conjugate. So since we have square root of 5 plus 2x minus square root of 5 here, the conjugate I'm going to multiply by is square root of 5 plus 2x plus square root of 5. So here we have plus square root of 5 over, and of course I have to multiply on the bottom because otherwise we would have a different value. Okay, so when we multiply this out, we're going to get this squared minus that squared. So that's 5 plus 2x minus 5 over x times square root of 5 plus 2x plus square root of 5. Okay, these 5's are going to cancel. Now we have 2x over x. We're going to cancel this x with that x. So we're just going to end up with 2 plus 2 over. And if we look at this square root of 5 plus 2x, now we can start plugging in x equals 0. So that's just going to be equal to square root of 5. So square root of 5, so 2 over square root of 5 plus square root of 5, that's just going to be 1 over square root of 5. And that's the answer to this limit. Okay, that was the last problem for today. I hope you found this helpful because this is definitely a very important topic that you're going to have to do. Make sure to remember all your steps and the 3 strategies for simplifying limits, and I'll see you in the next video.